this problem here has lots of nth powers, so I'm thinking geometric, but a really big thing about geometric is you cannot have a subtraction in there if you've got a common ratio. So you must split it up. So first off, I have the sum of 2 to the n over 6 to the n minus sum of 3 to the n over 6 to the n. And it's okay, like I'm doing, to just leave the n equal 1 to infinity off, because they're almost all 1 to infinity. Let's simplify this. Doesn't this give me a 1/3 to the n? Or you could think of 1 over 3 to the n, right? And then this one over here, I would get a 3 over 6 to the n. Wait a second, isn't that just 1 over 2 to the n? Yes. So the a in this case would be 1 over 3. The r would be 1 over, 1 over 3. In this case here, the a would be 1 over 2. The r would be 1 over 2. Since the a and r in both cases are less than 1, they both converge. And so this orange sum would converge to 1/3 over 1 minus 1/3. Excuse me, and keep the subtraction between them, right? And then this one would be 1/2 over 1 minus 1/2. That's a fine answer, just like that. Okay, so I'm combining things just to make sure you know how to change gears. So converge or diverge when there's sums, right? And it'll say if converge, find the sum. These are back to sequences. So, of course, your quiz and test will have both of them. So let's remind ourselves, when we're dealing with sequences, we just take the limit. Oh, and this one here, because I see this -1, I know I'm using ASR. So that means I take the limit of just the positive part, 3n squared, 2n squared plus 4. By taking highest powers, you don't need to do L'Hopital's. Excuse me. I get 3/2. Oh, since that does not equal 0, then I get that the whole thing diverges by ASR, alternating sequence rule. This one here, I'm going to try to take a limit. This n goes to infinity, and I really do want to know what the number to the nth power is. So thinking about this, isn't that the same as saying 27 to the nth power? This here, here's a different color, this here is the same as saying 4 to the n times 4 to the -1. So let's think about what 4 to the -1, that means 1/4, and so that turns into 4 out in the outside. And I'd have limit as n goes to infinity, and so the number to the nth power would be 27 over 4. Well, for sure that equals infinity because of that R limit rule. You don't need to say it, but that number is greater than 1, so the limit is infinity. So that means this sequence diverges. So in general, you take a limit, and it goes to infinity, sine of n over 3. I put it in infinity, I get sine of infinity. Wait a minute. You know sine does that forever. As n's go to infinity, does sine go towards anything? No, the limit does not exist. So therefore, I can say that the sequence diverges. This one's different because if I start to take the limit, I get dne over infinity. Oh, bells go off. Right, I need to use squeeze theorem. So I start by putting in sine between, if it's just sine, it's between -1 and 1. Then I can divide everywhere by 4 to the n. That's the denominator. So I have here what this is. So then I just go work the limits. And as n goes to infinity, -1 over 4 to the n, that's 0. Limit as n goes to infinity, 1 over 4 to the n, that's 0. So therefore, I can conclude that the one in the middle converges to 0 also. All right, last one here. I'm recognizing that this is an ASR, right? ASR. I'm just going to take the limit of the positive part. And as I'm writing it down, I'm thinking, I think I might need to use L'Hopital's, right? Because it's infinity over infinity. So if I'm using L'Hopital's, make sure you change it to x's. Derivative gives me 1 over x. Derivative gives me 1. Put the infinity in, I get 0. Since the limit of the positive part is 0, the whole thing converges to 0 also.